Hello, I'm Anirban, part of Team 141. I'm here to present our final poster for the project eVision, which is an intelligent vehicle recommendation system. So, what is eVision? It's a decision engine that helps car buyers answer one simple question: what is the true cost of switching to an electric vehicle for that particular customer? Instead of forcing people to juggle multiple calculators, blogs, and guesswork, it unifies trusted data into one transparent, interactive tool. The result is a clear, personalized view of cost, range, and emissions over the time. So the main problem and vision for our application. Most drivers hesitate to switch to electric vehicles because the trade-offs are confusing. It can be the upfront price, or it can be the fuel versus electricity cost. It can be the maintenance, or it can be the depreciation. Existing tools are fragmented and often hide their assumptions. So buyers are left making high-stake decisions with incomplete information. So eVision's goal is to close their information gap and turn a complex research process into a guided, data-driven experience. A little bit about the data that we have leveraged as part of our application. We have built our application based on the various datasets availed by EPA, which is the Environmental Protection Agency, and EIA, which is the US Energy Information Administration, and also various developer APIs which are publicly available, which helped us extract the real-time data related to the application features. The main idea is to collect, aggregate, and transform this data together to compute the TCO, which is the total cost of ownership model that includes the fuel versus electricity cost, insurance, registration, maintenance, and depreciation for both electricity vehicle and gas-driven cars. Multi-objective engine and visualization. The tool doesn't just return a single best car, but it filters vehicles by hard constraints like budget and minimum range. Then it scores remaining options on normalized dimensions like the cost, emissions, and range. Users can adjust their weights, such as it can be cost focused or it can be like environment based. And the application then recomputes a composite score in real time. This transparent user control weighing makes it clear how rankings change when priorities change instead of hiding everything behind a black box recommendation. A little bit about the experiments that we have performed as part of our application. What we found, the experiments showed that the automated TCO closely matches the detailed annual calculations, staying within about 2% efficiency, which builds confidence in the model. Location specific data proved critical. Regional differences in gas and electricity prices can drive 20 to 40% swings in the total ownership cost for identical vehicles. Tests within different user preference weights showed that rankings can change dramatically, validating the value of a flexible multi-objective engine instead of a one-size-fits-all answer. Lastly, I would like to conclude by discussing about a future scope of the application. In the current version, the application is completely rule-based. It would be great to have a model-based approach for the recommendation system. We can either integrate a regression model or a XGBoost model to predict the recommendations, which would enhance the output even better. Thank you. I hope you enjoyed our idea for our project.